Now that we have seen how software can revolutionize business processes, let's get back into the technical aspect and let's see how artificial intelligence is transforming technical process, especially in grinding. Carla Ferreira Andrade Cunha, I don't know how to pronounce it correctly. I hope it's correct, Carla, from the Institute of Machine Tools and Factory Management at the Technical University of Berlin, will introduce us to the use of artificial intelligence for in situ assessment of the residual stress state in the gear grinding process. Super excited because it's a fascinating combination of traditional machining methods and cutting edge artificial intelligence technology. Carla, stage is yours. I'm really excited to hear you talk.
So thank you very much for this opportunity. Hello, everyone. My name is Carla. I'm here today to present to you this presentation with this title, In Situ Assessment of Residual Stress State in Gear Grinding Process, an Artificial Intelligence Approach. I'm from Brazil. I am resistant assistant there in the technical Aeronautical Institute of Technology there. And I'm here doing this research in cooperation with IWF in Technische Universität Berlin. So I'm very glad to present to you this topic today. Okay, so this presentation will be divided in three topics. So first, we will talk about the motivation of this research. Then I will explain to you the methodology we are using right now, and I will finish with the next steps. So this research is based on the new technical requirements we are seeing in the industry right now. We need high speeds, lower dimensional tolerances, high productivity. And this is leading to new concerns about surface, about durability and reliability of mechanical components. My research is based on gears. And when we talk about surface integrity on gears, we can highlight here residual stress. Because when we have different residual stress, more compressive or more tensile, it can affect the fatigue life of gears. So our idea here in this research is using residual stress as a tool for manufacturing. Okay, this idea is not to use residual stress is not starting right now. It started in 2018 with this concept, named Design for Residual Stress, DRS. The idea of this concept is to try to design the gear and its manufacturing chain, thinking about the final residual stress to enhance the fatigue life of gears. So this research started with my research group in Brazil, and they defined some major information that is important right now. The first one is that the residual stress is not a product of one process only. It's a product of the whole chain. So it's important we pay attention in the residual stress we have in each stage of the manufacturing chain. Also, analyzing that, some colleagues of mine, they define some forms to predict residual stress first, because first we need to predict after control. So we are in that moment now, how to predict that. We already have some numerical predictions working well, but they are still offline. So it's not possible to apply in industry, in the shop floor. So the idea here, this new research we are developing together with Germany, is to develop an in situ assessment of that. To do that, the first thing we have to look is, okay, how is the ways we have right now to assess and control residual stress? We have, for example, to assess residual stress, the X-ray diffraction technology. It's very used, but have some key challenges here regarding position dependent, time consuming, and could be destructive depending on where you want to measure this residual stress. So it's not possible to be used online in a shop floor. Also, when we talk about control, and we can use finite element models, it's also a problem to use it online because of the time. and also because it's very limited for the boundary conditions of each model. So the idea now is to use new technology of Industry 4.0, for example, artificial intelligence. We already researched about that, and we know that it can be used to in situ assessment of other variables. So the idea now is to use that to predict residual stress in that moment. So based on that motivation, we defined this methodology. So we will apply artificial intelligence in the prediction of residual stress. The idea is to develop an in situ approach. So first, we started looking for in the literature what we already have about artificial intelligence in grinding. When we think about prediction of residual stress, we don't have right now any study ready. So it's a limitation we found. And then we try to find another, to look for other process. And we find some results regarding to milling and turning, but also even these studies that we find had some limitations when we think about in situ prediction. First, they use a small number of samples. In the average, only 30 in the studies that we found. It's not an appropriate number for machine learning application. So this is a limitation we want to fix. And the second is that only one of these studies are considering online process loading, which is very important for online applications. And in the end, the last limitation that we find, it's none of that studies. It's considering the interaction, or in other words, none of them are considering the whole manufacturing chain or more than one pass, for example, in each process. So now our contribution here will be focused on develop this online prediction algorithm using machine learning, and then considering this influence in the manufacturing chain. Okay, looking for all these observations and paying attention to that scientific gap, we state that hypothesis that a machine learning model can be able to predict the residual stress in shop floor, and then we define the objective of our research. So our objective right now is to develop and evaluate a machine learning framework to support this in situ assessment of residual stress state in gear grinding. So you can see we choose this process of gear to try to apply our research, because gear grinding in this case will be the last process in the manufacturing chain. So will be possible to evaluate all the influences we will have in the other manufacturing process of the chain. So how it will work? We will use the artificial neural network to apply this. This will be the algorithm we choose, and we have to choose to develop a database with input and output data to training this algorithm. So we are working together with Berlin, with IWF, and we are developing a design of experiments with a lot of samples to changing the process parameters. The idea is to create a lot of different residual stress states and then create a database that we can use to train that algorithm. So about this, how we will do that experiments. The experiments we will use 40 gears in the first moment, and we are doing a pre-grinding first because these gears were heat-treated, so we need to reduce the heat treatment geometry deviations. And then we will do this DOE with 2 grinding paths, because our idea is try to identify how one grinding path will influence in the other grinding path. That's our idea to can understand the process influence between grinding passes and about this influence of manufacturing in this first research. Okay, and then also we will use in each grinding, we will split each gear, in 7 sectors. One will be the control group, and the other 6 we will use with different combinations of process parameters. So we can have a greater database, which is very important for machine learning applications. Our idea is to reach more or less 200 experimental samples in this first research, which it's not a huge number, but comparing with other research we have right now, it's an interesting number. Regarding the instrumentation, our idea here is to do this instrumentation as less invasive as possible, because our idea is in a near future, try to implement that in a shop floor. So thinking about that, we will use data for a machine-integrated force measurement that we already have there in IWF in Berlin. So we will use that. They have a Capnile ZP12 machine that we will use to the experiments. And we also will collect machine information from the interface of this machine. So observe that our idea here is to facilitate this instrumentation for future. About the residual stress assessment, so after all the samples were grinding, which we are doing right now, the idea is to cut each tooth of the gear, because we need to access the residual stress in the pit diameter of each tooth. So, and we will have a partnership with Brazil, the university I come from, and there they have X-ray diffraction equipment where we will measure the residual stress of all samples. And that will be used as an output of our model in the training phase. Okay, so how the artificial neural network will work here? First, we will have the gear samples, and we will do the grinding experiments. Then we will measure the residual stress, and then we will have to treat all this data. It's important to do this phase of treatment, cleaning the data, and we have to pay attention in the analysis phase, because we have to understand if this data is okay or not to be an input of our model. So we'll do some data analytics analysis here, and then we will store it. Then we will have our database, and we will use this database in an input layer and in an output layer. The input, we will consider the previous residual stress, because we are considering the influence between grinding passes. We will put the process loading that we are collecting during our experiments, and we are also using the cutting parameters. There is easy information to obtain. The output of the model is the surface residual stress in the pit diameter. That is the variable we are trying to predict. So we will do the training of this model, and then the idea is after the training, it can be able to see new data and predict the residual stress. Also, we will use some techniques of machine learning as grid search and cross-validation, trying to enhance the results, because we don't have a lot of data, and data is very important for machine learning. So we will also use these techniques. Okay, this is our methodology that we are applying right now. This research is not ready, but we have some next steps to show to you. First, this is a basic research that we are being developed in cooperation with Brazil and Germany. But we have some next steps regarding to a bigger research with that theme that we already submit for founding in a binational collaboration. We already have some industry support, but of course, we need more. And our idea is to enhance the investigations. For example, in the part of digitalization process monitoring, okay, we have these 3 institutions on board of this project. Fraunhofer IPK from Berlin, they are there to focus on these digitalizations to find more ways to get this data. We have IWF Berlin, helping us with the knowledge of the process of grinding. And also we have the Aeronautics Institute of Technology from Brazil, focused on the artificial intelligence, which is my field, and also the residual stress. Okay? So thank you very much for your time. I have some contacts here. You can enter in contact with us if you need, and I will be here for questions if you have. Thank you very much.
Carla, thank you so much for the excellent presentation. Exciting
you.
topic. Before I start asking a few questions, what I'd like to ask the audience, are there any questions from the audience? Now would be the perfect moment to ask them. If not, I start, and then you can follow. Carla, I mean, usually you have to do like X-ray diffraction afterwards in order to assess the residual stress. Is that something we can get rid of in the future then?
Sorry, can you repeat
We
that?
can get rid of in the future. So
Yes, yes,
Yeah.
yes. The idea of this kind of algorithm, you have first to training that. So I have to present to the algorithm the information. So the idea is after a lot of training, because of that I need a lot of samples, it will work without this output. This output is just a way to say, oh, it is right, it is not right, and then he will learn. So the idea is in the future what would be necessary to use even for every moment to use the X-ray diffraction, because it's not feasible for production. You measure every sample. So that's the idea, not to use that in the future.
So you were talking about roughly above 200 samples that you need for your basic study
Yes.
for them at the moment. But I mean, what we want to achieve is a high accuracy in the later stage in order to get rid of X-ray diffraction, because otherwise, how many samples do you think the algorithm will need to get to the stage where I could say, as a producer, for example, of gears,
Yeah.
I don't need to care about assessment afterwards because I have my AI in place. So how many samples will be at least so the basis we will need?
When we talk about the number of samples in machine learning, it's also complicated because, okay, more samples is always better. But I believe, thinking about other research I already did in other fields, that if you will work with, I don't know, near 1,000 samples, will be a huge number. But I truly believe that with 200, we already will get some important data, because important results and good results. Because using that techniques that I comment, grid search, we can try to augment this data and get more interesting results. So I think with this 200, we have okay, I start. But in the future research, I think near 1,000 will be enough.
Let me tackle the last topic about your starting point in your presentation. You mentioned like electromobility, and I'm a big fan of electromobility.
Oh,
I must
nice.
admit. I mean, this is not the fashion right now in Germany. Everybody wants to push it down, but it's still running. So if I have a look at the car manufacturers and looking at your development and the gear thing. Yesterday, we had another portion of that where it's also very important to have a perfect grinding quality in that topic because it would enable more durability, etc. Are car manufacturers already involved in these kind of studies, or are they interested? Are they asking for that? Because that would not revolutionize, but at least optimize their business a lot.
Yeah, yeah. That's our idea, because we know with the electrification, the gears will have more attention because they have to be more strong. They have not to be noisy because we don't have the engine anymore. And I think to use this kind of technology in electrification can help the sector. I know we already have a good quality of gears, but I think with the time, we will need more and more to improve this quality. So this will be a way to improve this quality in the shop floor.
Yeah. AI is always about relation between quality factors and outcome and dependencies, let's put it
Yes.
that way. So we are considering now the grinding process at the gear. and we can consider the gear as a total after production. Would it be helpful to have as well data out of the use of the gear afterwards? So you know what I mean? You have produced the gear, you put it in a car or whatever where it's running,
Yeah.
and you get of how does the residual stress affects the use later on? Would that be data that would like push your model a little bit further?
Yes, we can have this kind of approach. It will be change a little the approach. Now we are talking about just to predict residual stress, but this kind of approach we are talking, it's very important for other research to understand better how residual stress is affecting the fatigue life, for example, of gears. In my group of study in Brazil, we have some research involving that kind of research. Not specifically using artificial intelligence, but they have other methods.
Yeah.
But this will be an interesting topic to then trying.
I mean, I started my working life in quality management and automotive,
Yeah.
so I would really see it as a future aspect where we can save all the, let's say, reactive quality measurements by
Yes.
having an in-situ assessment already in production, and that will give us all the data that we would need for calculation, for planning our services afterward, durability, etc.
Yeah.
So Carla was an excellent presentation. I loved it.
Thank you very
An
much.
excellent topic. I wish you all the success possible and for good results for all of us, of course.
Of course.
So keep on going, keep the pressure, and thank you so much, and good luck for your next part of the project.
Okay.
Carla, ladies and gentlemen, big
Thank you
applause.
so much.